Okay, so in this video, I mostly just want to point out that numbers are relatively easy to teach. So for example, we can show clusters of 3 objects and then have it annotated with, like, in the Orca language, of course, number 3 or so. And of course, at this point, they don't know what the concept number means or so, but we just annotate it there to make clear that we're looking for this, like, property that they will learn from that. And yeah, might be useful later. And yeah, and then we can of course test it again with, like, showing them. Oh, I just noticed. Yeah, here are 3 dots, by the way. Yeah, so and then we can show them, of course, like 3 other objects or so, and then see whether they and then, like, start with the word number and then make the tone for, like, yeah, you're expected to respond, and then see whether they can generalize in Sage 3 or so. And same for, like, other numbers too. And the way I would, like, encode those numbers as, like, words is, like, that we use some structure. So, like, for example, like, we have some number prefix. I just, like, use some yeah, like, I don't know, something arbitrary, just to indicate that, like, a number is following, which, by the way, is different from this number. I think, like, I probably want to make it different. And then, like, we have some relatively natural number encoding, for example, like, 3, like, small hills for the number 3, like, or like, I don't know, after that prefix. And like, then, like, after this is 4, like, it gets a bit long, so we use something else for 5, and it's also useful so that like, I'm just using decimal numbers here, just because it's easier than to communicate with humans, because we naturally think of that. And yeah, we can use something else for 5, like, and then 7 is just or I don't know, like, yeah. And yeah, like, then we can check whether they can count. Like, we have some sequences of, like, numbers in this format, like, which we can also play, and then, like, see whether they can continue the pattern. And yeah, like, I would, as said, use decimal system. So I don't know, like, maybe have the number prefix, like, shorter if we use decimal, like, for indicating the next digit or something. But yeah, basically, like, if we have 13, we just have a 1 and a 3. And yeah, like, addition is also easy. Uh, like, I mean, it of course depends whether they can learn, whether they have the right kind of intelligence for that, though I would expect yes. But I don't know. Like, not sure for multiplication, but I don't know. Yeah, like, uh, yeah, like, I would write addition like this. Yeah, so as already mentioned, like, I think this is more natural because plus is a 2-place function, but then, like, we know there's an end here, and then we can just use the equality on this side rather than having it on this side. Yeah, not totally sure whether it's best though, but probably. And I mean, we can, like, equality is of course also like a 2-place function. We could also put it on the front and then, like, indicate this is like 1 parameter, and then, like, some other parameter is needed, but I don't know. Yeah, and then we can just see whether they can repeat like, whether they can notice the pattern from, we show them lots of patterns, and then we show them exercises of, like, oh yeah, what's, like, 2 plus 4? And then, like, oh, okay, yeah, maybe they generalize correctly and be like 6. Yeah, multiplication, you can, like, there's also a simple pattern you can build up from using, like, 2 times 4 equals 4 plus 4, 3 times 4 equals 4 plus 4 plus 4, and, like, they can notice that pattern or so. And yeah, I don't know. takes probably some time to learn, but yeah, I don't know. And generally, like, I mean, if they are totally new to math, then they probably aren't very good at it in the beginning. But uh, like, we can do like number like IQ test stuff, where like, okay, find the pattern in such and such sequence where it's like always like times two minus three, times two minus three, or something, and then we can see whether they can find that pattern or different patterns like always times two. I mean, times two is already like one of the harder ones, which would come after having learned multiplication and so on. But um, yeah, plus three, minus one, so like patterns like that. And and yeah, like I mean, if they master it, we can go harder and like show a Fibonacci sequence, which would be really impressive if they manage to find that even after some thinking. But yeah, I don't know. Or like probably easier, like the squares where like the differences have like constant differences, um, like square numbers 1, 4, 9, and so on. Yeah. Something else I want to say here. No, I think that's it.